Today, we're going to take a look at the enigmatic Toyota 4A-GE engine. Now, this is a classic engine that a lot of people love. I'm going to talk to you about how to build them and what some of the pitfalls are with these engines and how to avoid them. First off, the 4A-GE is actually a really fragile engine by today's terms. It was designed by Toyota to make a kind of puny 114 horsepower. That was a lot for back then, but not too much by contemporary terms. I mean, it's basically a classic engine. There's some cool things, like it was one of the first production 4-valve twin-cam motors that you could buy in the U.S. It was like one of the highest revving engines you could buy at the time. It revved up to 7,500 RPM, which was unheard of. This was an era when V8s only revved to like maybe $5,000 and 4 cylinders maybe revved to 5,500. It was a really cool engine for the time. It's a pretty neat engine if you have like a A86 chassis to stick it in, and even some of the front wheel drive stuff like the FX16, if you remember those. Our customer is building this engine to put in his daily street-driven A86, and it's kind of like a slight resto mod restoration kind of engine. We can get into this, and I can talk to you about some other things you can do while we're discussing it. First thing I wanted to discuss about is the block. The first generation 4A-GEs that came in the A86, for instance, the 95 and 96 Corolla GTS had what's called a Gen 1 engine. So this is a big port, but kind of small crank block. This engine's actually pretty darn weak. It has small rod journals, small wrist pins on the rods, and the block doesn't have any reinforcement, so it's a pretty flexy flyer. It's fine for minor builds, but once you start approaching 170 horsepower at the crank, it starts to develop problems. The crank starts breaking, and when you approach 8,000 RPM, the block starts flexing, and you have problems like the main caps getting beat out and your bearings getting chewed up. So, you know, if you have a minor naturally aspirated bolt-on A86, it's fine, but if you want to do more, there's other alternatives. This particular engine has what you call a third generation small port block. This is probably the best block to use. It has a lot of external reinforcements like ribbing to make the block stiffer. The crankshaft has bigger journals, 2 millimeters bigger. This is really important, and it has bigger rod bearings. It also has a 20 millimeter pin diameter for the rods as opposed to 18, and it has oil squirters for the cylinder walls and the pistons. If you're going to build a engine, this is the one to use. It was, I think, like 1988 to maybe 1992 production. Not all of those years were the US market, but this is where you want to start to build a block. Another good block is the supercharged MR2 block. It has about the same features, and the front wheel drive, like the A92 front wheel drive Corolla, that block has a lot of the same features. Those are all good basis to start your more modified 4A-GE motor. So we're going to talk about the crank here. This is a bigger journal crank, as found in the third gen block, also the second gen blocks. The second gen blocks have just about all the same features, but they have an 18 millimeter piston pin, and they don't have the squirters, but they have the stronger crank and the stronger block, which is the important part. So we have bigger journals. It's a fully counterweighted crank. It's pretty strong for a 114 horsepower crank, but you can't like totally lean on it. Probably this crank is probably good for about 200 crank horsepower, or maybe 170 wheel horsepower. It doesn't seem like a lot, but when you think about how little power this thing had in the first place, it's pretty good. Where the early cranks broke is back here and back here, these two journals near the end of the crank. So if you revved much past 7,500 RPM for very long, or if you exceeded 8,000 RPM frequently, you would break the crank there pretty quickly. But these cranks are a bit stronger, and if you're building a, like a nice kind of healthy performance rebuild, this is the crank to use. Now, if you're going to get more power, you probably have to use a billet crank. Brian Crowder makes a stroker crank, and MRP in New Zealand, they make all kinds of pretty mean stroker cranks for these that are made out of billet. So if you're going to go serious horsepower, like reach into the 200s, if you're going to rev to like 9,000 RPM, for instance, billet crank is the way to go. Like I said, this later, bigger journal crank is pretty good up to 8,000 RPM. Pretty good for a street motor. This particular motor, all we did was balance the crank, kind of cleaned up some of the casting flash, polished the journals. We magnafluxed it before we even started to check for cracks, but we didn't do anything heroic. You could cryo treat it or WPC treat it, but the owner didn't want to pop for that, so that's basically all we did. So when you're seeing the crank and the block, bearings are really important, because bearing failure is a big problem with these 4A-GEs. The stock Toyota bearings get chewed up real easy. A lot of it's because of the weak flexing crank and the flexing block. So we use King or ACL bearings. These are modern bearings that are much more durable and have higher load bearing capacity than the bearings back in the day. They're a good choice. Of course, you can cryo and WPC that, but that's like your prerogative and an option. Going back to the block, the way it is just fine for a mild street build. On this particular motor, we just kind of cleaned up the flash and bored it out. We used a torque plate. The torque plate simulates the stress of the head being bolted on the block, so when you bore it, cylinder walls come out nice and straight, just like they would as if the cylinder head was bolted on. That's basic good practices that we normally use. We also use a 600 diamond hone as the final hone. And to finish it off, we use a plateau hone to kind of take the points off the hone surface to help the rings seat, reduce friction, and reduce wear. These are just some tricks we do on all of our engines. If you're really going to get more than, let's say, 200 horsepower and you're going to exceed 8,000 RPM to rev it to 9 or even higher, you're going to have to do something to reinforce the bottom end. There used to be any number of companies that made parts to do that, but now probably MRP in New Zealand is the only people that make anything. They make like a steel billet main cap reinforcement that just kind of bolts on top of your stock caps with longer studs. That's probably the minimum you should do. And now if you're building a more extreme engine, like trying to rev past 9 and you're trying to get 250 naturally aspirated horsepower, or a big turbo engine, they make a whole bottom end girdle that you can put. And this is the way to go. Like, it ties the pan rails into the main caps and really increases the block rigidity. And this is something that's really hurting on the 4A-GE. So the MRP main cap reinforcements or their girdle, when you're going big power, those are important to get. One of the big weak points of the 4A-GE is the oil pump gears. The stock oil pump gears are really weak and they break. Like they'll probably break promptly if you exceed 8,000 RPM. This is a pretty bad problem. Back in the day when we used to race these things, a lot of gear failures. There's a couple of things you can do, like for like a hot street kind of performance NA build. Toyota makes a set of hardened reinforced gears that just drop in to replace the stock parts. I think for the money, that's a pretty good thing to do. And if you're building a big power motor, there's dry sumps available from MRP. That's going to assure your lubrication. And you know, if you're revving past 9, that's definitely the way to go. But the Toyota gears are good for most people. You can get the stock gears and WPC them. That helps a little bit, but why not just get the assurance and get the Toyota gears? You know, like we also would do things like WPC treat the housing, the gears, break the edges of the oil passages to kind of help your flow, and then break the edges of the high pressure bypass just to make sure the valve doesn't get hung up. Those are little tricks that we do for a lot of engines, but that's what you could do for your oiling. Like I said, I really recommend the Toyota gears for almost any kind of build. For connecting rods, we're using MRP rods. MRP, the New Zealand company, they have these on the shelf. They're readily available. They come with the bigger 20 millimeter piston pin. That's almost an essential thing because the 18 millimeter pins get beat out really quick. For this particular engine, we're using CP pistons. These are a nice shelf piston. They're made out of 2618. They have a lot of modern features like a pressure equalization groove, dual pin oilers. We've talked about dual pin oilers in the past. Basically, they're a passage that takes oil that the oil ring scrapes off the cylinder wall, and it pressure feeds the piston pin so it stays well lubricated. These are like a pretty good conventional piston. I mean, super high quality. They're kind of high compression. Like the shelf piston is a 12-to-1 piston. That's a little bit high for California pump gas, so we're going to be milling the top a little bit to get the compression ratio down to 11-to-1. If you have 93 octane and you're using a standalone fuel management system, you could probably get away with 12-to-1. But for California gas, our gas really sucks. So we're going to be on the safe side, reduce the compression to 11-to-1. But these are a great piston. MRP also has great pistons. They just have to come from New Zealand, but the exchange rate's pretty good. You can get a lot there. On the induction side, we're running ITBs. Now, since this is a streetable motor and the owner wants torque, these are 40 millimeter. I think if you wanted to get a max effort naturally aspirated motor, for instance, you might want to go to 45 or 50 millimeter. But for a torquey street motor, 40 is fine. Plus, they look really cool. For engine management, we're going old school. So the owner of the car is using Apex Power FC. This thing gets rid of the flap door airflow meter, which basically sucks on these cars. Makes it alpha N with a barrel reference, so that's pretty good for performance, and it's just something off the shelf. For the cylinder head, we're using the older style big port head. The small port head is pretty good. You know, the 3rd generation small port. They have smaller intake ports. That's pretty good for just like a bolt-on engine. But you know, all the race engines, like the Formula Atlantic motors, use the big port head. So these have big intake ports. So this is a big port head on the 3rd gen block. So it's kind of a hybrid. The owner didn't spend a whole bunch on the head. Just kind of like the minimum you need to do to get a super reliable head. These are HKS cams. These are old school cams. They have 288 on the intake duration, 272 on the exhaust. These 4A-GEs back in the day were run with more intake than exhaust duration. It's kind of a Japanese thing. Something I maybe don't agree with that with this kind of engine, with the mismatch of intake to exhaust flow, but it was a Japanese thing. This is back in the 80s. These cams have 8.5 millimeter lift. Your stock lift is 7.5 millimeters. And if you want to go more than stock lift, you have to do a few things. The cam followers on these are shim on top of the bucket. And when you run a high lift cam, the higher lift tends to just flip the shims out of the follower. It's kind of like a tiddlywink. So you're going to get massive valve clearance and probably drop a valve, as well as eat up and ruin your cams. So what was done back in the day was to convert everything to shim under the bucket. So you would have a bucket, and then the retainer would have a well to put a little shim, and then the bucket would sit on top. Now, all those parts from TRD and other companies got discontinued, but SuperTech has saved the day, and they've kind of reissued these parts. So if you're a contemporary 4A-GE builder, all the SuperTech parts will enable you to go to shim under bucket, and that's what was done with this engine here. Back in the day, there was a whole bunch of cams that were built for to maintain 7.5 millimeters lift, so you can run the stock shim on top of the bucket, but nowadays you don't have much choice. If you're running a cam with when the lift starts approaching 10 millimeters, you have to notch the cylinder head where the buckets go in, so the lobe will clear the casting. It's not necessary on 8.5, but in case the owner ever wanted to go to contemporary cam, we notched the sides for them. For contemporary cams, we really like the Kelford cam. Kelford cam has the best valve motion of the cams available nowadays, so you get a lot of lift for the duration and a lot of area under the curve. So Kelfords are a more modern grind. They'll give you more power. If this was going to be my personal engine, that's the cam grinds I would use. To prep these heads, they don't really need a lot of porting, especially the big port heads don't anyway. So basically what we did was a Newen valve job. This is when we have a CNC machine do a smooth radius valve job. It actually goes from the combustion chamber into the ports, and it's just a smooth continuous radius with only the 45 valve seating surface. This smooth radius greatly helps low lift flow. On some engines, we've actually picked up 50 horsepower over a traditional high quality 3-angle valve job. So we like to use the Newen machine on a lot of our Sirius motors. This engine has a Newen valve job, and we hand blended the ports. So the bottom cut of the Newen machine made, we blended that into the port wall, kind of cleaned up the casting flash in the bowl, and kind of broke the edge of the short side radius. That's all you really need to do in these big port heads, and you can make pretty decent power just doing that. The owner opted to run standard size valves. If it was my motor, I would probably go to a slight oversized valve. That's what SuperTech has. But generally, you can make a pretty healthy engine as long as you don't get too greedy with the revs. This engine is a fairly simple, economical build. It should make about 160 wheel horsepower. I mean, the stock engine makes something like 80 or 85, so that's pretty decent. If you wanted to go a little healthier, be kind of initial D, I would say billet crank, like a 1.8 liter stroker, Kelford cams, and the main cap reinforcement. That could make maybe 200 to the wheels and be more torquey and be pretty fun. Of course, it would cost some, a little bit more, but it wouldn't be too bad. Now, if you want to go really crazy, MRP has lash ups to where you can use later variants of the 4A motor and get up to 2 liters. And they have all the tricks to, I don't know, build a 250 horsepower plus NA motor or a probably 800 horsepower turbo version. MRP is a really great company for those of you that love the 4A-GE. I would check out their website and see all the cool things they have available, because they've continued to develop the 4A-GE, you know, way past when everybody else gave up. But that's it in a nutshell. The 4A-GE is a cool engine for your restored AE86, or if you have an FX16, you'll have a lot of fun. Those are really small, lightweight cars. They're awesome. The only thing is they're getting rare and expensive nowadays, but want to build a 4A-GE? We have a lot of experience. I used to be an engineer for TRD back in the day, and Howard, our lead engine builder, he was one of the top mechanics at TRD, so we basically grew up on these things. So if you like this content and you want to see more, be sure to go to MotoIQ.com, check out all of our articles. We have a really cool article on the more extensive 4A-GE build there, and down below we'll give you the link to that. Check us out on social media, Instagram and Facebook, and if you want us to build you a 4A-GE or just about any other motor, at MotoIQ, go to the Pro Services link and fill out the form and we'll get back to you. So I hope you enjoyed this, and I hope you continue to increase your MotoIQ.